Hi, everyone. I wanted to do a little mini lecture on pedigrees. This is homework for module 6. And I know there's a question on an X-linked disorder. And so I just want to share my screen and I'm going to show the questions. The first one was number 13. And here is the problem. So Tony has anosmia, and this is a disorder that prevents him from being able to smell. So they don't have a sense of smell. This disorder is an X-linked recessive condition. So it's related to the X chromosome, one of the sex chromosomes, right? Tony being a male, he has an X and a Y. And then we know that Tony's wife, Samantha, has a normal sense of smell. Remember, Samantha is a female, so her chromosomes are XX. Then we got to Tony's family, right? And so Tony's sister, Haley, has a normal sense of smell, as does her husband, Phil, and daughter, Sandra. However, Haley and Phil also have identical twin boys, Josh and Andre, and neither of them can detect odors or smell. So we have to relate to Tony and Haley's parents, and we have to say that Tom and Dolores can smell normally. So the first question here is to determine who's a carrier and who has the condition. Of course, we know who has the condition, right? Tony and the twin boys. The rest of the family have normal sense of smell. So we have to kind of like start working backwards, right? So we have to put all their names. So I'm going to do a new share here and have my whiteboard, and hopefully I can write with my pen here. So we know that Tony doesn't have a sense of smell. So Tony has the condition. So the condition, we're going to write it like this, right? A for anosmia, which is the condition that you cannot smell. This is an X-linked recessive disorder. So it's obviously in the X chromosome for Tony. And because he got that allele that is affected, so he cannot smell. Then we know that Samantha, his wife, can smell. So her genotype is that she can smell. Her phenotype must be this one, right? So the capital A is that she can smell normally, right? So the afflicted allele is lowercase a. Then we know that Haley, which is Tony's sister, right? She can smell normally. So she must be this kind, right? Because you only need one to be able to smell correctly, right? And she can smell correctly. So Haley could be that one, or she could also be this one. And we should say the same with Samantha, right? Now remember, sorry, this is a big A. Remember that in order to suffer from the disorder, you only need one allele in the X. But with females, one of the X chromosomes is inactivated, right? Is the Barr's body. So they most likely are this kind, right? But we don't know yet. We have to see the children, right? So Haley is married to Phil. And Phil can smell, so he definitely is this type, right? This genotype, because he can smell normally. And then Haley and Phil have twin boys. well, first they have a daughter named Sandra, which she's able to smell normally. So again, Sandra must be either this or she must be this, right? She smells normally. Remember, we only need one allele to suffer from the disorder, and we don't know until they cross, until they have family, right? What kind of genotype they are. We know their phenotype, we don't know their genotype for sure. And then Phil and Haley also have Josh and Andre, and the twin boys are affected with anosmia. So for sure, their phenotype is that one, right? So another information that we have is that Tony and Haley's parents, which is Tom and Dolores, they can smell normally. So we have to also assume that Tom, if he can smell normally, he doesn't have the allele for anosmia, right? Because he's a male, and if he had it, he could not smell. So he should be this genotype. And then Dolores, if she had a son, Tony, with anosmia, most likely Dolores is this one. So that she gave Tony this one. Yeah, I know it's a little scratchy on my whiteboard, but that's the first question, right? That we want to know who is what is the genotype for all of the family members, right? So now I want to draw the pedigree. So I'm going to clear everything here, and I'm going to start with black now. So we have to start with Dolores and Tom. So Tom and Dolores are Tony's and Haley's parents. So we know that we do the females as a round and a circle, and we do a square for the females. So on this side, we're going to have Tom. Now we know Tom is normal smell, right? Both parents are normal smell. So Tom, being a male, he most likely, or no, most likely, he has to be this way, right? The capital A is normal. So because he's not affected, we're not going to shade it in. Now, Tony has anosmia, so he got something from his parents. If it's not from Tom, which is normal, it has to be from his mother, Dolores. And Dolores most likely has the anosmia gene, right? So because she has a normal allele, she's half shaded because we consider her a carrier, right? We know from our problem that it says that Tom and Dolores can smell normally, but they had two children, right? So they had Tony, which cannot smell. So Tony is for sure this kind, right? Because he cannot smell. So we're shading. Oh my God, I made Tony a female. Tony, which is a square, he cannot smell, right? And they also had Haley, which is a sister. Now Haley can smell, right? But she has two twin brothers that cannot, sons that cannot smell. So we have to assume that Haley is a carrier, just like her mom, and she's going to be this kind. Okay, so far so good. Parents can smell normally. Then they have Tony that it has anosmia, cannot smell, detect odors. They also have Haley, which is Tony's sister, and she can smell normally, but she had two sons that are affected. So I'm assuming that she has to be a carrier because we know later on that she gets married and Phil is normal. So the recessive condition has to come from this side of the family, right? So then we know that Tony gets married to Samantha. So remember how we do our little straight line that they get married to Samantha. And we don't know Samantha, really. We have to see their offspring, right? So we don't have any offsprings yet. So Samantha, since we don't know, she could be this, or she could be this, right? They don't have children yet, so we don't know what they are, Samantha is. So we're gonna know for sure if we have children from Tony and Samantha. But Haley gets married. I'm just gonna erase this here a little bit. And I'm gonna put Haley's possible, let's see, possible genotype. Oops, what happened here? Undo. I'm gonna draw. Perfect. So we're gonna put Haley here. Okay, so Haley gets married to Phil. Now Phil is a male, so he has normal sense of smell. So his genotype should be this one, right? So the capital A is normal smell phenotype. So then they have 3 children. You know how we put the 3 children here. They have Sandra, which has normal sense of smell, right? Now, Sandra, again, hasn't had any children. So her possible genotype is going to be either this one or it's going to be this one, little a, big A, right? So either of those two is going to give her a good sense of smell. But since she doesn't have children, we cannot for sure say what is the genotype. So it's the same case with Samantha here. But then Haley and Phil have 2 boys. 2 boys where 2 boys. And we have the other boy. And they both are affected. So we have Josh and we have Andre. So for them to be affected, they have to be like Tony, right? So they have to be X little a y and X little a y. So because we know that Josh and Andre are affected, that's why I know that they got these little allele from mom, right? From here. And where did Haley get it? Haley got it from Dolores. And where did Tony got it? Tony got it from mom. So we know that the whole family disease or disorder started with Dolores. But Dolores is just the carrier, right? So we have to say that Dolores is a carrier, half shaded. This one is a carrier. Sandra may or may not be a carrier, right? Because we don't know yet. Same issue with Samantha. We don't know for sure who's going to be, how's going to be their progeny, right? Their next generation. So that's how we solve this problem, pedigree problem. And of course, you have to make sure that you do both here because we don't know for sure. So you have to put both genotypes in this little problem here of pedigree. So the next question is, what if Haley and Phil have another child, a boy, and normal sense of smell? What are the chances to have a boy and, which is the word that tells you that we need to multiply the chances of probabilities, right? So to have a boy and have a normal sense of smell. So we're going to clear everything here. And now we're going to do question 14. And these are, what are the chances of probability? Remember that if you see the word and, that means that we multiply both of the probabilities, right? So with this, we have to do a Punnett square for Phil and Haley, right? So we know Haley is a carrier. We know Phil is normal. Oops, that's a big A. So we do our Punnett square. So that would be like this. That would be like that. And then we do here and here. And then we do here and here. So what are the chances of them having boys? So we have 1 and 2, right? So they have a chance of 50% of having a boy, right? So 50% is 1/2. And then the other question is, and what are the chances that they're going to have normal smell? So out of the 2 boys, out of these 2 boys, what are the chances that one is going to be normal smell? And we can see there's only 1. So again, there's a 50% chance for normal sense of smell. And that will be like this. And they're asking me for the total probability. So I do 1/2 times 1/2, and that will be 1/4 of a chance, or 0.75 or 75%. So that's how you calculate the probability when they're asking you for 2 things, and the word and indicates that you have to have a multiplication in there to answer the question. So I hope this helps a little in how you arrive to solving pedigrees and probabilities. I'm going to post this and I hope you can watch it, and happy 4th of July. Bye.